Today on Supernova, we observe our own natural satellite, the Moon. Some young astronomers show us the ropes, and we play the cosmic harp. Welcome to Supernova. I'm Eric Dunn. The Moon. It's familiar and breathtakingly beautiful, but it's also cold and alien. It's because of this dichotomy that some observers just can't get enough of it, including Gary Seronik, who's an expert on lunar observing.
The Moon as we see it today is really the same Moon that the dinosaurs would have seen. Not much has happened lately. In fact, one of the most recently formed craters, a very prominent crater named Tycho in the southern part of the Moon, formed 109 million years ago. Up until recently, we didn't really have a strong preference as to which theory describing the Moon's origin is the one that we held closest. But since the last little while, basically the analysis of the Apollo mission samples have led astronomers to come up with the Big Impact hypothesis about the formation of our Moon. What we think happened is that a large body struck the Earth about 4.5 billion years ago, perhaps something as big as the planet Mars, collided with the Earth, and the debris that splattered out into space and slowly fell into orbit around the Earth coalesced to form our Moon. The surface of the Moon we see is basically almost entirely the product of two processes. One process is impacts. The second process is lava flooding. And what happens when you have a large impact is it actually excavates a fairly substantial depression. And then when that later fills with molten lavas, you get what is called a mare, which is Latin for sea. When you're looking in your telescope, big craters will have certain features that smaller craters won't if you look carefully. Big craters, for example, will have a central mountain peak or central mountain peak complex, where smaller craters are more simple. They're basically bowl-shaped depressions. This is one of the telescopes I use for viewing the Moon. It's an 8-inch reflecting telescope. Although you don't really need a telescope as big as this one to enjoy viewing the Moon. In fact, any telescope will show you an astonishing amount of detail on the lunar surface. And you can even see a fair amount with an ordinary pair of binoculars. The phases of the Moon are important because they determine where the terminator lies on the Moon's surface. And the terminator is the line that divides night and day on the Moon's surface. And that is the best place to view with a telescope because you're getting the maximum shadow relief and details stand out in stark contrast. When you see the Moon as a crescent in the evening sky, one good thing to look at is Mare Crisium. And it's an interesting feature to watch for a number of reasons. One is it's just visually interesting, but also if you watch it often enough, you'll notice that its shape changes depending on the libration angle the Moon has. Sometimes it'll appear as a oval squashed up against the limb of the Moon, and other times it'll appear almost circular. And as we approach first quarter Moon, a whole raft of interesting features come into view, and maybe my favorite is a trio of craters, Ptolemaeus, Arzikel, and Alphonsus, which are near the middle of the Moon, and each of those craters is distinctly different from the other, and they're fascinating to look at in a telescope. After first quarter, we get into sort of the less interesting part of the Moon, I suppose, where you have more mare surface because it's dominated by Mare Imbrium, one of the largest features on the Moon. But even there you can see interesting stuff when the terminator is nearby. For example, even though the mare looks very smooth, when the terminator is going across the mare, you can see that there are little subtle topographic features that start standing out. And then after that you get into full Moon, where again you have no terminator, so there's no shadow relief, but a good time to look at ray craters and to look at subtle gradations and the shadings of the mare regions. And then once you get past full Moon, you basically have this cycle of phases in reverse, and you're seeing things illuminated by sunset illumination rather than sunrise, which you were before. So you see the same features and you still want to look in the same area along the terminator, but you just get a different illumination angle, and that can make some features look a little bit different. One of the things that kills amateur astronomy for a lot of people is the fact that with all the city lights, it's harder and harder to see the faint, far away things. The Moon doesn't have a problem with that. The Moon can be seen under the brightest of city skies or the darkest of country skies. It doesn't matter. There's no real advantage to one sky over another. Whereas a lot of other things we view in our telescopes, we really do need to be under dark skies to see.
Astronomy is a hobby that inspires children. But when we met Ronan Kerr, he inspired us. At 12 years old, Ronan is the president of an astronomy club for kids, and his enthusiasm is infectious. We met with Ronan so he could show us some great stargazing activities for kids.
I've been into astronomy for 4 years, since I was 8 years old. I have a 12-inch Dobsonian telescope. I won it at the 2008 Merit Star Quest. My favorite object is a whirlpool galaxy in the constellation Canes Venatici. It's my favorite object because in a telescope like my 12-inch Dobsonian, you can easily see the intricate details in the spiral arms. One important tool that helps astronomers find objects is called a star wheel. A star wheel is a rotatable map of the sky that can be adjusted to the precise date and time of observing. We are going to use the star wheel to locate the star Vega in the constellation of Lyra.
The first thing you must do when you're using a star wheel is to set it to the exact time and date when you're observing. Let's assume it's July 9th at 10 p.m.
Find Vega on the star map. Now turn so that you are facing north and hold the star wheel so that north is at the bottom. Follow the meridian up from the horizon, directly overhead. Vega is the brightest star in the area and can be easily seen at 10 p.m. because there are no other major stars in the area to compete with it. Now that we have found Vega, we can use the star wheel to star hop to the keystone of Hercules. West of Vega is a bucket-shaped group of 4 stars known as the keystone. On the west side of the keystone is the globular cluster M13, one of my favorites. M13 looks like a tightly packed group of millions of stars. You need binoculars to see M13. M13 is 2/3 of the way up between the fainter lower star and the brighter upper star of the bucket. Patience is required to find objects for the first time, so if you have any difficulty, ask a parent or other astronomer for help. M13 looks great through a telescope of any size, even the smallest. Here's a 60mm refractor that I'm going to show you how to set up.
To help set up the telescope, we've enlisted 2 members of Ronan's astronomy club, Elsha and Michael.
The first thing we have to do is extend the legs. Next, we'll attach the legs to the tripod head. Now we can put on the accessory tray. This part is called the yoke. Place the telescope into the yoke and use the screws to lock it in place. Tighten the yoke screw. Secure the finder scope to the telescope tube. The finder scope gives a wider view of the sky, making it easier to locate objects. Next, insert the angle prism into the focusing tube and secure it. Lastly, insert the eyepiece into the angle prism and tighten it in place. Setting up a telescope isn't as hard as it seems. It gets easier every time. With the telescope fully assembled, we can now study the star wheel and wait for the sun to go down. I hope you will enjoy astronomy as much as I do. It's a great hobby and activity for people of all ages.
Lyra is an old constellation, and its 4 stars suggest the outline of a harp. It was said that the harp played celestial music only heard by the pure of heart, and therefore completely inaudible to modern populations. Epsilon is a tiny dot to the eye alone, but clearly double in binoculars. A telescope reveals that each member of the pair is itself double. The bottom pair of the box contains Beta. This is a variable star and it sinks in brightness every 13 days. Usually Beta matches Gamma, its partner on the box. They are both 3rd magnitude stars. But in an eclipse, Beta falls to fainter than magnitude 4. The difference is easily seen without optical aid. Sweep with low powers between Gamma and Beta and a tiny spot is seen. Carefully change to a medium power eyepiece. This is the famous Ring Nebula, a cloud of gas around an elderly star. Finally, Lyra's cool heart is Vega. Noticeably pale blue, it is a gem high overhead on sultry summer evenings.
There are lots of ways for kids to get involved in astronomy. You can draw the phases of the moon or build a scale model of the solar system. And if you get really good at star hopping, you can find any object in the sky. But kids have a lot of questions, and sometimes they need help. So if you encounter children at a star party, pass along your knowledge and your passion for astronomy. Thank you for watching Supernova. I'm Eric Dunn, wishing you clear skies.